Hello, Marcel here to show you Lucid's particle flow geometry operator. Besides being able to simulate fluids with particle flow, it is also possible to use it to simulate Lucid objects in different kinds of geometries for each particle inside your particle system. And today we will look at this by exploring two different scenarios. In the first one, we're going to simulate a whole bunch of little inflatable or soft body objects, each represented as a separate particle. And in the second one, we will try to do something more complex and simulate rain falling onto a puddle of water. So let's start with the first example, and I will do this one from scratch. So I'm going to go to particle systems and create a particle flow source, and then I will create a proxy geometry object. We will use this geometry object to represent each particle inside the particle flow, so it's going to be actually instanced by the particle system. I'm just going to create a quick little cylinder, and it's going to be somewhat small because we're going to have it for each particle, and I'm just going to move it aside a little bit so it doesn't interfere with our particle simulation. So I'm going to go into my particle flow source object and open the particle view. Just need to select it and click the particle view button to get the particle view window to show up. And once inside my particle view, I need to do a couple of things to actually instance this cylinder geometry inside this particle flow source object. First thing I will do is set my display as geometry as opposed to ticks, so we can see the final geometry. Right now it's displaying the boxes. And second is I need to set my shape to be a geometry from inside my scene. To do this, I'm going to use the shape instance operator, and I'm going to replace the shape operator that was there before with it. Once I do this, I select my cylinder as the shape, and now we have all these particles generating cylinders inside the system. So next thing I will do is create a little collision object, so the cylinders will not just keep falling down, and I'm going to just reset the first frame and create a quick sphere which is going to encompass everything. I'm going to apply a normal modifier, so we flip the normals so that it is actually facing inwards in a way where it will catch all of our objects. And inside object properties, I'm going to use the back face call so we can actually see our particles. Just turn off the grid here, and I'm going to set the sphere as a static collision object. Once again, you can do this by using the static collision object preset from the Lucid toolbar. So now if we just scroll through the timeline, we can see that there's a whole bunch of different cylinders being generated. We probably don't want this many cylinders this fast, so I'm going to go to my birth operator and change the emit stop to a higher value. Maybe it can stop emitting at frame 100, and then maybe I will also stretch my timeline a little bit just so we're simulating more frames than we did by default. I'm relatively happy with this. And now I'm ready to use my new Lucid operator. So I'm going to use the Lucid geometry operator and not Lucid fluid operator, which we covered in the previous tutorial. I'm just going to select it and insert it at any place within my event. And once I do that, all of the cylinders will stop dropping. They will just kind of appear in one place. And this is normal while our simulation is not turned on. So the next step I will do is select my Lucid geometry operator and set the body type to inflated. So all of our cylinders will be an inflated object. And one thing I need to do, if you recall from previous videos, is that I need to go to my Lucid Flex settings and change the default particle radius. I'll just set it to something like 3. So now if I press simulate and if I scrub through my timeline, you can see that all of these cylinders are being generated as soft body objects, and they're actually interacting with the collision object and they're ending up on the bottom of it. So it looks like right now there is some interpenetration happening. To take care of this, I'm just going to exit my simulation and change the particle radius to a bigger value. Let's try something like 5. And if we simulate now, we can see that the cylinders are colliding with each other better and they're not penetrating each other as much. So one other cool thing that we can try is actually deleting the cylinders by age. And this will be useful if you're trying to do something like continuous emission of particles where you don't want them all to stick around until the end. To do this, I'm going to add the delete operator. I'm just going to place it right below my Lucid geometry operator. I'm going to turn off my Lucid simulation for now. I will set the particle age to be something like 40, and you can preview this inside the viewport by just sort of scrubbing and seeing how these objects are created and then they're destroyed. Maybe I will also change the size of my PFlow emitter just so that we get some nice spatial variation of where particles are born. So let me simulate again. Now you can see that these objects are all dropping inside the sphere, but they're also disappearing after some time. So we can really stretch our timeline and not worry too much about how many objects we have, because the simulation will remain at constant speed due to the particles disappearing over time. time. And we can try to get some more interesting results by increasing the amount of particles emitted from 200 until 2000. This will effectively increase the number of cylinders that are generated, and it will increase the number of particles that we have within our fluid simulation. And even if I scrub right now, you can see this is pretty fast and interactive as far as simulation goes. If I want to keep my results just as I did before, I can always use the record button, and when I press it, it's going to go through my whole scene, and then it will record all of the shape changes that we have happening to our cylinders, even as they are born and destroyed. Once the simulation is done, the button is no longer active. I can go back and play the whole scene in real time, and this time no simulation is happening, so this is pretty quick and responsive in terms of being able to scrub your scene back and forth. Of course, you can save this file and it will save the simulation with it. So this is an interesting introductory example and one of the possibilities of using Lucid particle flow geometry operator, but something far more interesting is changing the type of object that we're simulating. So right now we are simulating inflated object. Just the same way you can have rigid objects or soft bodies, and the next example that we will use will actually have fluid objects being generated. So one of the scenarios that I thought up of when thinking about the usages for the new particle flow operator is the ability to create raindrops that fall onto a puddle of water or some other liquid. So I quickly set up the scene, and in this scene I have this box representing my puddle of water. I just have an external collision object that is a black box. This little sphere here will represent a single water droplet, and then I have this particle flow source, which is basically creating these drops and also destroying them, just like we did the cylinders in the previous scene. Inside the particle flow view, we see that I have the same kind of setup as we did before. So the particles are being born between frame 0 and 200. About 8 of them are created, and then we have our shape instance, which is using this drop model sphere. For our droplets, we have the Lucid geometry operator, which is set to fluid this time, and it is not displayed as particles. I have modified the density a little bit from 1 to 0.6 to make them bounce on top of the water a little bit, but this is something that you can really play around with until you find the effect that you want. Then I have the delete operator, which deletes my particles after 40 frames, and they are being displayed as geometry. I also set some settings in my global simulation, so I preset the particle radius to be 3 centimeters. I changed the number of sub-steps and iterations to be quite low, and then I disabled the maximum particle velocity and I set it to a manual value of 600. I have also turned off the display of particles for my puddle object, just so that we get nice mesh display for both the spheres and the water beneath it. The droplets are going to be different color from the water, but we can change this later on. For now, it's just for demonstration purposes. So if I press simulate, we can see that the water right away settles into an initial state, which I have predefined before. And as I scrub, the droplets start being created and they are dropped into my water puddle. And this is pretty fast and responsive, considering that this is also doing meshing in real time for all of these objects together. And the spheres are creating a little splash. The particles are interacting with each other, and then the spheres disappear after some time, where their effect no longer matters to the overall scene. And this allows new spheres to be created and new droplets to be dropped into my water without really increasing the time which it takes to simulate this scene. So let's skip ahead and just record the overall simulation. And once it's done recording, just like before, we can play back the scene very smoothly and quickly, and all of our geometry will stay saved with our 3ds Max file. Let me just change the color of both the water and the geometry to be the same value, and I'll just select something that looks sort of like water. When I do this, it's much harder to tell where the droplets and the puddle are different geometry, and we get a much more natural effect of raindrops falling into a little puddle of water. So this is just one of the uses that really shows off the power of the particle flow geometry feature for Lucid, and I'm sure there are many other effects which can be achieved in a similar fashion. I have used sort of very small resolution and large particle size in this case, but I have done so just for the ability to be able to quickly demonstrate this in a demo scene while also recording this video. You can probably crank up the number of particles quite a bit to get much more realistic water effects. I'm going to make this scene available for download in our sample section, so feel free to grab it and try the simulation locally or on your own computer and see what kind of parameters are being used, and maybe play around with the settings a little bit. So I hope you find this feature useful and you will be able to incorporate it into your own workflow. Thank you very much for watching.